In this video, we're going to finish the KutaSoftware Infinite Algebra 2 free worksheet planes. Picking up on the second page, we're to sketch each plane and write the equation of each trace. So let's start by sketching that plane. And in order to sketch the plane, we need to find those intercepts. So finding the x-intercept, that occurs when y and z are 0, so x equals 3. So we're going to plot 3, 0, 0 for the x-intercept. The y-intercept occurs when x and z are equal to 0, so that's y equals 3. So we're going to plot the point 0, 3, 0. And then lastly, that z-intercept occurs when x and y are equal to 0. So that leaves us with negative z equal to 3. And dividing by negative 1 or multiplying both sides by negative 1 gives us that z is equal to a negative 3. So we're going to plot the point 0, 0, negative 3. So let's graph each of those intercepts. 3, 0, 0, that's 3 forward. 0, 3, 0 is 3 to the right. And 0, 0, negative 3 is going to be 3 down. And remember, in order to sketch that plane, we need to connect the x-intercept to the y-intercept, or vice versa, the x-intercept to the z-intercept, or vice versa, and the z-intercept to the y-intercept, or vice versa, y-intercept to z-intercept. And each of those lines is the trace. So the x-intercept to the y-intercept is the trace, and that occurs on the xy plane when z is equal to 0. So in order to find that xy trace, we're going to set just z equal to 0 in our equation. So that'll leave us with x plus y equal to 3. So our trace of that line is x plus y equals 3. Now let's find the trace of xz. And that occurs when y equals 0. So it's going to be that line from the x-intercept to the z-intercept. So now writing the equation for that line, we're going to set y equal to 0, and that will give us that x minus z equals 3. So the trace of xz is x minus z equals 3. And then lastly, we're going to find the trace yz, which is that line from the y-intercept to the z-intercept. And that occurs when x is equal to 0. So y minus z equals 3 is that trace, or the equation for that line. And now I'll just shade in that plane. So there's our sketched plane, and there is each trace for the plane. Let's do the same in number 10. In number 10, starting with the intercepts, the x-intercept will occur when negative 6x equals 12. So negative 6x equals 12. I'll divide both sides by negative 6 to get that x is equal to a negative 2. So our x-intercept is negative 2, 0, 0. So I'll go ahead and plot that, which is 2 back. Now for our y-intercept, that occurs when x and z are 0, so 3y equals 12. And dividing both sides by 3, I'll get that y equals 4. So my y-intercept is 0, 4, 0, which when plotted is 4 to the right. And then lastly, that z-intercept, when x and y are 0, 4z equals 12. So writing that equation, 4z equals 12, I'll divide by 4 to get that z is equal to a positive 3. And graphing that intercept 0, 0, 3, I will be 3 up from the origin. Now we're going to find each of our traces. We have the xy trace, we have the xz trace, and we have yz. So xy is from that x-intercept to that y-intercept, and the equation of that line. And that occurs when z is 0. So that's going to be negative 6x plus 3y equals 12. However, each of these terms is divisible by 3. So I'm going to divide the left-hand side by 3 and the right-hand side by 3. And let's make that 3 a negative so that we're similar to that answer key. So negative 6 divided by negative 3 is a positive 2. So I'll get 2x plus 3 divided by negative 3, which is negative 1y. So minus a positive y equal to 12 divided by negative 3, which is negative 4. So 2x minus y equals negative 4 is my trace, xy. Now onto the trace for xz. That occurs when y is equal to 0. So negative 6x plus 4z equals 12. And each of these is divisible by a 2, and let's divide by a negative 2. So that will leave us with a positive 3x minus a 2z equal to 12 divided by negative 2, which is a negative 6. So 3x minus 2z equals negative 6 is the trace for xz. So I'll go ahead and graph that line. 3x minus 2z equals negative 6. So from x to z. And then lastly, my trace yz, that occurs when x is equal to 0, which is 3y plus 4z equal to 12. And those do not have a common factor, so my trace is 3y plus 4z equal to a positive 12. So I'll go ahead and draw my trace from the z-intercept to the y-intercept, or vice versa, y-intercept to the z-intercept, and then shade in my plane to finish my answer. So there's my sketched plane with my traces. Let's continue on to number 11. In number 11, my x-intercept occurs when 3x is equal to 12. So 3x equals 12, dividing both sides by 3, I'll get that x equals a positive 4. So 4, 0, 0 is my x-intercept. So that's 4 forward. My y-intercept is when negative 6y equals 12. So negative 6y equals 12 when, if I divide by negative 6, that's when y equals a negative 2. So 0, negative 2, 0 is my y-intercept, and that's 2 to the left. And then lastly, my z-intercept occurs when negative 4z equals 12. So dividing both sides by negative 4, I'll get that z is equal to a negative 3. So plotting 0, 0, negative 3, that's going to be down 3 from that origin. Now let's start by finding our xy trace. That occurs when z is equal to 0. So 3x minus 6y equals 12. However, for 3x minus 6y equal to 12, they each have a 3 in common. So I'm going to divide the left side and right side by 3 to get that x minus 2y equals a positive 4. And that's my trace equation. X minus 2y equals 4. And let's go ahead and draw that trace from my x-intercept to my y-intercept. That is my equation that forms this line. So if we were to look at this in the 2D or 2-dimension, x minus 2y equals 4. We could write that in slope-intercept form for our coordinate system in the 2-dimension. Now, let's find our xz trace. Now the xz trace occurs when y is equal to 0. So that's 3x minus 4z equal to 12. And 3, 4, and 12 do not have a common factor. Therefore, 3x minus 4z equal to 12 is the equation for that trace. So from my x-intercept to my z-intercept, that line has the equation 3x minus 4z equals 12. And then lastly, from y to z, that occurs when x equals 0. So negative 6y minus 4z equals 12. And those are all divisible by 2. So writing negative 6y minus 4z equal to 12. I'll divide both sides by a negative 2. So that my coefficient with y and z are positive. And that will be a positive 3y plus 2z equal to a negative 6. So my trace for yz in number 11 is 3y plus 2z equal to negative 6. Now I'll graph that from the y-intercept to the z-intercept, or z-intercept to the y-intercept, and then I'll shade that in to finish my plane. And that's my solution to number 11. Now, on to number 12, the last problem in this section. Let's start by finding that x-intercept that occurs when negative 3x equals 6, because y and z are 0. So negative 3x equals 6. I'll divide both sides by negative 3 to get that x is equal to a negative 2. So I'm going to plot negative 2, 0, 0, my x-intercept, which is 2 back. Now for my y-intercept, that occurs at 2y equals 6. So when 2y equals 6, that y value for my y-intercept will be 3, because 6 divided by 2 is 3. So I'll have 0, positive 3, 0 for my y-intercept, which is 3 to the right. And then lastly, for my z-intercept, x and y are both 0, that's negative 2z equal to positive 6. So negative 2z equals a positive 6. I'll divide both sides by negative 2 to get that z is equal to a negative 3. 0, 0, negative 3 is the coordinate for my z-intercept, and that's 3 down. Now it's time to work on our traces. We have the xy trace, we have the xz trace, and we have the yz trace, which is essentially the equations for the lines that connect those intercepts. So we're going to find the line for the xy trace, which is the line that goes from the x-intercept to the y-intercept. Then we're going to find the trace xz, which is the equation of the line from the x-intercept to the z-intercept. And then lastly, we'll find the trace for yz, which is the equation for the line from the y-intercept to the z-intercept. And I'll go ahead and shade this in now to form our plane. Now let's find each of those equations for our traces. The xy trace again occurs when z is equal to 0. So that's negative 3x plus 2y equal to 6. And negative 3, 2, and 6 do not have a number all in common as a factor. Therefore, negative 3x plus 2y equals 6 is the trace. However, on the answer key, the coefficient associated with x is positive, so let's just multiply both sides by negative 1. So that'll be 3x minus 2y equal to negative 6 as our trace for xy. Now for the trace for xz, that occurs when y is 0. So that's negative 3x minus 2z equal to 6. Which again, we want our coefficient of x to be positive so that it matches that of the answer key. So we're going to divide or multiply both sides by negative 1. That'll give us a positive 3x plus a 2z equal to a negative 6 for the trace for xz. Again, that's 3x plus 2z equals a negative 6. And then lastly, for yz, that's when x is 0, so 2y minus 2z equal 6. However, 2y minus 2z equal to 6, each of those has a common factor of 2. So if I divide the left-hand side by 2 and the right-hand side by 2, I'll get 1y, or y, minus 1z, or z, equal to 6 divided by 2, which is 3. Again, because 2 divided by 2 is equal to 1, I have y minus z equals 3 for that yz trace. And that is my solution in number 12. Now onto the critical thinking questions. Number 13 says, write the equation of a plane with intercepts 2, negative 3, and 4. So our equations are in the form of ax plus by plus cz equals some variable, let's call this d. Now our x-intercept occurs when y and z are 0. So we have that ax equals d, and we're given that that x-intercept is 2, so a times 2 will be equal to d. Now for our y-intercept, that's when x and z are 0, so by equal to d, and that y value that's associated with that is negative 3. So b times negative 3 equals d. And then lastly, for our z-intercept, that occurs when x and y are 0. So we have c times z equal to d, but z, our z-intercept is 4, so that's c times 4 equal to d. So we can simplify these by dividing this first equation by 2, the second equation by -3, and this third equation by 4 in order to get our coefficients by themselves, which is what we're trying to solve for. So we will have a equal to d divided by 2, b equal to d divided by -3, and c equal to d divided by 4. So I want to find some d value that is a multiple of 2, -3, and 4. So let's go ahead and make our d value 12. So if d is 12, that means that a equals 12 divided by 2, b will equal 12 divided by -3, and c will equal 12 divided by 4. So a, 12 divided by 2 is 6, b, 12 divided by -3 is -4, and c, 12 divided by 4 is 3. And remember, that is if d is equal to 12. We could have chosen a different multiple, however, 12 is the least common multiple of those factors. And now look, we have a, b, c, and d, which are the numbers we need to write our equation. So plugging 6 in for a, we'll get 6 times x plus plugging -4 in for b, as opposed to adding a -4, I'll simply subtract 4 times y, and then plugging 3 in for c, I'll be adding 3 times z, and that will equal, plugging 12 in for d, 12. And that's my solution in number 13. And we could have chosen a different value for d, finding another multiple, however that equation still would have simplified down to 6x minus 4y plus 3z equals 12. So finding the least common multiple of all those intercepts at the start will make writing that equation for the plane easier. So again, what I did is I found a common multiple, the least common multiple, between those intercepts and set that equal to d, and then once I plugged that value in, I found each of the coefficients given our intercepts. Now let's continue on to the last problem of this worksheet, number 14. Number 14 says to write the equation of a plane with a y-intercept of 2 and an xz trace of 2x plus z equals 8. So if 2x plus z equals 8 is our trace, that trace is for when y is set equal to 0. However, if we use the fact that our y-intercept is 2, we can first solve for the y-intercept and then be able to plug that value in for that trace equation in order to get the full equation, because remember the trace equation is when y equals 0. So our equation of the plane will be 2x plus some coefficient, let's call that coefficient b, times y plus z equals 8. So our x-intercept occurs when by equals 8, and they give us that that intercept value is 2. So setting by equal to 8, given that our y-intercept value is 2, so y will be equal to 2, I'm going to solve for that coefficient b. So b times 2 equals 8, and that's the y-intercept, so when x and z are 0. So all I need to do is divide by 2 to find that coefficient b, which is a positive 4, because 8 divided by 2 is 4. Now I can take that b value and plug it back in to get my equation of the plane. 2x plus 4y plus z equals 8. That is my solution in number 14. And again, explaining this one more time now that we've worked through it, my trace occurs when y equals 0. However, I know that y is not 0 because we're given a y-intercept of 2. And that y-intercept is solved for when x and z are 0. So my coefficient times y equals 8 is the equation used to help me solve for my intercept, but I know that that intercept is 2, so I'll plug 2 in for y and solve for my coefficient b. And that gave me b of 4, so then I just took that value of 4, plugged it back in for my coefficient of y, which was the only coefficient missing from my entire equation, because the coefficient of x was 2 and the coefficient of z was 1, and the coefficient I solved for of y, which is 4. So again, my solution in number 14 is 2x plus 4y plus z equal to 8. And with that equation, we would get a z-intercept of 8 and an x-intercept of 2x equal to 8, which when divided by 2 would be an x-intercept of 4, if we were to take this problem further. However, it only asks for that equation, so we'll stop here. If you have any questions, please feel free to leave them in the comments below, or if you want to leave me a note, just put that in the comments below as well. And if you haven't done so before this worksheet, click that like button and subscribe to my channel. All likes and subscriptions, as well as shares, are greatly appreciated. So go ahead and do that now. And once again, thanks for your support.